Okay, calculus, I am not intending to hurt your feelings or insult you in any way, but just to make sure that we don't forget things that students tend to forget. Let's go over determining the equations of lines given certain pieces of information. So for the first one, I'm asking you to find the equation of a line that passes through a point and is parallel to a different line. So the two pieces of information that we need to determine the equation of a line is its slope and its y-intercept in some sort of fashion. So for the first one, we are going to use this point, sorry that it went across the line there, to find the y-intercept, and our slope is going to come from somewhere else. So for our line in general form, it will help us determine the slope. We have 3x subtract 2y equals 5, and our line is parallel to this line, so our slope will be the same. So in order to determine our slope, I am going to rewrite this in y equals mx plus b form by subtracting 3x from both sides and dividing both sides by -2. So I will end up with y equals 3 halves x minus 5 halves. Who cares? I just wanted the slope. I have found a slope of 3 halves. So my line is going to have a slope of 3 halves, and I am going to substitute my point -2, 5 into the line with the same slope to find that y-intercept. 5 equals 3 times -2 plus b, 3 halves times -2. I end up with 5 equals -3 plus b. I end up with b equals 8. Final answer. My line is y equals 3 halves x plus 8. The second one, we want the equation of the line that's perpendicular to the line. If my line is perpendicular, my line will have opposite slope. So my line will have the negative reciprocal of 3/4, which is -4/3. My line passes through a point. I can use that point to find the y-intercept by substitution. Substitute that point, the only thing that I know, into y equals -4/3 x plus b, and solve. -3 equals -4/3 times 4 plus b, not quite as pretty, -16/3 plus b. I'm going to add 16/3 to both sides. I found a common denominator of thirds. I have 7/3. Final answer, y equals -4/3 x plus 7/3. Okay, so those are two skills I really need you to file away, that you remember parallel and perpendicular, and that you remember how to determine the equation of a line. Again, not trying to be insulting. Here we go. Ooh, interesting. Determine the equation of the tangent to the curve y equals 1/x times x squared plus 1/x at the point 1, 2. So at a specific place. Let's just have a quick peek at this function for a second before we do our algebra. So it's this crazy thing with the asymptote in the middle. Let's play with it a little bit. If I want to find the equation of the tangent, I'm going to need the slope of the tangent. So in order to have the slope, I'm going to need the derivative. Okay, my derivative is y prime. So our notation would be y prime. I don't have function notation, so I don't put a number in brackets. So I'm going to write over at the side when x equals 1, or at the point 1, 2, something that indicates I'm looking for a slope at a specific place. So I'm going to be doing general case, and then I'm going to put a 1 in there. Okay, y prime. Well, I might want to do a little bit of tidy up first, because that thing is so ugly that I don't know how to use my power rule with it the way it is right now. So I'm going to tidy up a little bit. I'm going to take this thing and just write it a little prettier. So if I do distributive law, 1 over x times x squared, I get x squared over x, which is the same as x, plus. If I do 1 over x times 1 over x, I get 1 over x squared. Okay, that I could probably work with a little bit easier. I could continue to just write that so that it looks like powers, because that's easier to use my rules from yesterday. 1 over x squared is the same as x to the negative 2, and now I've got something I can work with. To find my derivative, I'm going to use that power rule, x to the invisible 1. I bring down my power and reduce my exponent by 1. For the second part of that function, I bring down my exponent of negative 2 and I reduce my exponent by 1. Okay, it's ugly, but that's my derivative function in the general case. So anything to the 0 is 1. I'm going to just make this thing prettier. X cubed. Okay. I've said that I want to find this derivative when x equals 1. So really, I suppose I should have written this 3 lines later. When x equals 1. Okay. When x equals 1, I have 1 subtract 2 over 1 cubed, which is negative 1. So the slope of my tangent is negative 1 when x equals 1. So I want to determine the equation. Just like we did on the previous page, I need a point in order to find the y-intercept. And I have my slope. So I'm going to substitute 1, 2 into the line y equals negative 1x plus b. 2 equals negative 1 times 1 plus b. Add 1 to both sides to find my y-intercept. And my final answer for this tangent line is y equals negative 1x plus 3. Let's draw it on our grid over the page. Negative 1x plus 3. Oh good, I can draw on this. I wasn't sure. Okay, so I have drawn the line y equals negative 1x plus 3, and I was looking for the tangent, the equation of the tangent at the point 1, 2. And there you can see the tangent line and its equation at that place. Next example, find the point on the parabola where the slope of the tangent is 5. Interesting. Okay. So first of all, let's look at that parabola for a second. Upside down has a y-intercept of 4, and we have some x-intercepts there that we don't have in this form. Okay, we want to know where the slope of the tangent is 5. The slope of my tangent is y prime. So I want to know where is y prime equal to 5. Okay, let's find y prime, or dy dx, or f prime of x, whichever you like. So this one is nicely laid out. I can use my power rule of yesterday where I bring down the exponent and reduce it by 1. So the first term is negative x squared. I bring down the 2. That becomes negative 2. X to the, reduce the exponent by 1 is a 1. The second term is 3x. I bring down the exponent, which is a 1, so that remains 3. And I reduce the exponent by 1, which technically is x to the 0, but I don't have to write that down. The derivative of 4 is 0, so I don't write that either. So the derivative function of our original function is y prime equals negative 2x plus 3, and I want to know where that is equal to 5. I'm going to solve for x, and that will tell me where. I'm going to subtract 3 from both sides, divide both sides by negative 2, and I have the place where the slope of the tangent is 5. Let's look on our graph and see if that makes sense to us. Where at x equals -1, the slope of my tangent should be 5. Okay. I'm trying to eyeball this. That is a slope of 5. And that looks like it fits beautifully right there. So the slope of the tangent is 5 at the point x, or where x equals -1, and that is the only place where the slope is 5. Just to quickly finish that question off, it asks us where the point is. We saw it. It's -1, 0. But just to be sure of that, if I want to find the point, I want the point -1 something by substituting x equals -1 into the original function. Okay. So y equals -1 squared plus 3 times -1 plus 4, just to verify that our 0 was correct. So I have -1, -3 plus 4 is 0. There, we have found our point.